Okay guys, it's looking a little crowded on my table here, but if you can follow this line, that's coming out of the battery, and we're going to go into this, which is the feed for the multimeter. Okay, so that's going to go into here, and you can see that we're set up to read milliamps on the milliamp scale, and my meter is turned on. From the negative, we're coming around here, and this is my negative feed, which goes to the yellow wire, which goes to bulb 1, the round bulb actually in this case, and then over to bulb 2, the long bulb, and finally all the way back. And what we're going to do is we're going to hook this on. Okay, and what we actually see here, a little bit different. Let it settle in here a little second here. Getting some varying quantities. I got a little bit of light in my long bulb, not much, and hardly any light in my round bulb. I settle in about 42 milliamps. Okay, so that's off the predicted value of what we had in the little magic white board. Now let me show you what we're going to do to measure the voltage. Do that again. Okay guys, here we are again. I've got my one battery, and this line comes around to the first bulb, and that line comes around to the second bulb, and then from that bulb, we're going to go back to the back of the battery again. So we've got our setup. You can see that the long bulb has some light on it, but the round one doesn't. And don't worry that the round one doesn't have light. We know if the light is going on here that there's still current in the system because there's only one set of current here. And if it wasn't going to light this bulb, then it wouldn't actually be going through this filament. In other words, if I unscrew this, watch what happens if I unscrew this bulb. You can see the light in the long bulb just goes out. Now if I screw it back in again, it's just like your Circuit Master game where you don't have a complete route between the values. Okay, so there's energy going through this bulb, but there's not enough to light it. Now you can see that my voltmeter's kind of going a little crazy here. It's got a bunch of numbers all over the place. But that'll settle down once we put our voltmeter on the bulbs. So I'm going to try the long bulb first. And I'm reading about 1.29 volts. And I'll try to pick that up while I keep these values on here. 1.29 volts. Now if I move my voltmeter over to the second bulb, I'm reading about 53 millivolts. 53 millivolts. So let me see if I can pick that up for you. Now it's reading about 92 millivolts. All right, 92 millivolts. So 92 and 1.2. Let's check what that is. Okay guys, real quick, let's check that total voltage. Now how would I check total voltage in this circuit? Well, to check the bulb 1, I would just touch on either side of the bulb. To check bulb 2, I would just touch on either side of that bulb with my two leads. But to check total, I can actually just touch where the circuit is connected. Now if I do this, I don't know if I can do this and show you. Reading about 1.5 volts. That's pretty much the reading of the battery. All right, you can see that we're losing voltage somewhere in the other measurements. Okay guys, so where did all that extra voltage go? From 1.5 we ran the total, and when we did it individually with each bulb, we only came up with 1.31, maybe 1.35 if you take some of those numbers that were jumping around. Well, we're going to talk about this more in upcoming episodes, but ultimately you got to ask yourself, what are the things in the system have resistance that could actually take voltage, where voltage could drop from one value to another? Because remember, gravitational potential is like a hill, and for the total hill, you got to get from the top to the bottom of the hill. So 1.5 volts of electric potential at the top and 0 at the bottom. So for every time you're going through something with resistance, and current's going through something with resistance, there's a voltage measurable drop. So we'll talk about that term a little bit more tomorrow. But if you think to yourself, what other things have resistance in that circuit that I'm not measuring? We did talk about the wires. So ask yourself, could the wires have a voltage drop? Could they use some of the voltage from the total and not letting it go be applied directly to the bulbs? These are things that are a little bit more complicated, and we're going to get those circuit values underway in upcoming episodes. But today, to answer that question, what happens when a long bulb and a round bulb are used in the same circuit? What did we learn today? Well, number one, we learned that both bulbs get the same amount of current because there's only one flow. And number two, each bulb does not get the same voltage. The bulb with the greater resistance, 31.5 ohms, that got the much greater voltage than the one with the lesser resistance. So the voltage, the bulb with the greater resistance gets the greater voltage. And the total of those voltages should add up to the total of the circuit, at least in theory. And then, of course, in practice, we were only off by maybe a little bit less than 0.2 volts. So we're okay there. I hope you guys learned something today. Don't forget, we'll have that Google form ready on Friday to give you guys as a summary. What I discussed today is not necessarily Chapter 34 material. I'm really more working on Chapter 35, but it was a great question we got in through email. So hope you guys are great today, and we'll see you tomorrow. Remember, Friday, Google form as a summary, and then we'll have a great break. Take it easy, guys. We'll see you tomorrow.